November the 12th, 1942, Richmond, California. The welding torches fell silent. The hammers stopped their rhythmic pounding, and for a moment, just a brief, impossible moment, the 18,000 workers at Kaiser Shipyard No. 2 stood motionless, staring at what they had done. 4 days, 15 hours, 29 minutes. That's how long it had taken them to build the SS Robert E. Peary, a ship that by all conventional wisdom should have required 6 months to construct. 10,000 tons of steel, an ocean-going vessel 441 feet long, a Liberty ship. But here's the thing that makes this story truly remarkable. The detail that transforms it from impressive to utterly world-changing. This wasn't an anomaly. This wasn't a one-time publicity stunt, though it certainly served that purpose. No. This 4-day miracle was merely the most dramatic expression of an industrial revolution that was, quite literally, keeping freedom afloat. Because while young men were dying in the cold waters of the North Atlantic, while U-boats prowled beneath the waves like steel wolves, and while Britain stood on the precipice of starvation, America was doing something that had never been done before in human history. We were building ships faster than they could be sunk. Now, I want you to forget everything you think you know about shipbuilding. Forget the romantic notion of craftsmen carefully fitting each timber, each rivet placed with artisanal precision. Because what I'm about to tell you isn't a story about traditional shipbuilding at all. This is a story about the moment American industrial genius looked at an impossible problem and said, "Watch this." Let me set the scene properly, because you need to understand just how desperate things were in 1940. Britain was alone. France had fallen in a matter of weeks, something that still seemed incomprehensible to military planners who remembered the stalemate of the Great War. The Wehrmacht stood at the Channel, planning Operation Sea Lion. And every night German bombers turned British cities into infernos. But the real war, the war that would determine Britain's survival, was being fought far from the headlines, in the cold grey waters of the Atlantic Ocean. The numbers were terrifying. In 1940 alone, German U-boats sent over 1,000 Allied merchant ships to the bottom. That's not just statistics. That's food that would never reach British ports, fuel oil that would never power British tanks, steel that would never become British aircraft. Every torpedoed ship meant British civilians would eat less, British factories would slow, British resistance would weaken. Admiral Karl Dönitz, commander of the German U-boat fleet, had calculated precisely what he needed: sink 750,000 tons of Allied shipping per month, and Britain would be forced to sue for peace within a year. And for much of 1940 and 1941, he was achieving exactly that. President Roosevelt understood the mathematics of survival. Britain needed ships, needed them desperately, needed them immediately, and needed them in quantities that seemed impossible. Traditional shipbuilding methods, refined over centuries, produced perhaps one merchant vessel every 6 to 8 months from a single shipyard. At that rate, we'd lose the war before we could win it. The British had already designed a solution, or at least the blueprint of one. Based on a simple, sturdy tramp steamer design from 1879, they'd created plans for an emergency cargo vessel. Nothing fancy. No speed records. Just a reliable, capacious workhorse that could carry 10,000 tons of cargo across the Atlantic. They called it the Ocean Class. But having the plans and actually building the ships were two entirely different problems. Britain's shipyards were already working at maximum capacity, and many were being bombed nightly. They needed American industrial capacity, and they needed it transformed in ways that seemed to defy possibility. Enter the US Maritime Commission, and a man named Admiral Emery Scott Land. Land looked at the British design, looked at American industrial capability, and made a decision that would reshape naval history. He took the Ocean-class design, simplified it further, made it even more utilitarian, and created what would become known as the EC2SC1 type, a designation that would mean nothing to history. But its nickname would echo through time, the Liberty ship. Here's what made Admiral Land's vision revolutionary. He wasn't thinking like a shipbuilder. He was thinking like Henry Ford. He was thinking about assembly lines, about interchangeable parts, about the American industrial system that had transformed automobile production. And he was about to apply those same principles to shipbuilding, something that many traditional naval architects insisted was impossible. Now let's talk about rivets. I know it doesn't sound exciting, but stay with me, because this is where the story gets fascinating. For centuries, ships were held together by rivets, thousands upon thousands of them, each one heated until it glowed cherry red, inserted through perfectly aligned holes, and then hammered, often by a team of men, until it formed a permanent connection. A skilled riveting crew working in perfect synchronization might install 300 rivets in a day. A single Liberty ship required roughly 1 million rivets if built traditionally. Do the mathematics. That's months of labour by hundreds of specialised craftsmen. And here's the problem. In 1940, America didn't have enough skilled riveters. The old guard, the men who'd learned their trade over decades, were aging out. Training new ones took years. We didn't have years. The solution came in the form of electric arc welding, a technology that had existed since before the First World War but had never been applied to ship construction on this scale. And the reason was simple. Many naval architects didn't trust it. They'd seen welded ships crack, seen structural failures, seen what they believed was proof that riveting remained superior. But circumstances demanded innovation, and desperation often breeds genius. Here's what made welding revolutionary for Liberty ship production. Instead of requiring a skilled craftsman who'd spent years mastering the art of riveting, you could train a welder in weeks, sometimes days for simpler seams. Instead of a crew of men working in careful coordination, one person with an electric welding torch could create seams as strong or stronger than riveted connections. More importantly, welding was faster, dramatically faster. Where riveting a single seam might take a crew hours, welding could accomplish it in minutes. And welded seams were actually lighter than riveted ones, roughly 600 tons lighter per ship, which meant more cargo capacity. But the real genius lay in what welding made possible for the entire production process. Because when you can weld, you can prefabricate. You can build massive sections of the ship, entire hull panels, deck sections, superstructure units, in separate areas of the shipyard, or even in different locations entirely, and then transport them to the ways for final assembly. This is where Henry Kaiser enters our story properly. Now, Kaiser wasn't a shipbuilder. In fact, he'd never built a ship before winning his first maritime commission contract. He was a construction man. Dams, bridges, highways. He'd helped build the Hoover Dam and the Grand Coulee Dam. He understood earth-moving equipment, concrete, and large-scale construction logistics. What he didn't understand, what he refused to understand, was that shipbuilding was supposed to be different, special, bound by centuries of tradition. And that ignorance became his greatest asset. Kaiser looked at shipbuilding and saw an automobile, or rather, he saw what automobile manufacturing had become under Ford's assembly line system, and he asked a simple question. Why can't we do that with ships? The traditional answer was, because ships aren't cars. They're too large, too complex, too individual. Each one is essentially a custom creation. Kaiser's response was, then we'll make them less individual. Here's how modular construction transformed Liberty ship production. Instead of building a ship from the keel up in a linear sequential process, Kaiser's shipyards divided each vessel into prefabricated sections, sometimes as many as 250 separate modules. These weren't small pieces. We're talking about sections that might weigh 30 or 40 tons, pre-assembled with piping, electrical conduits, ventilation systems already installed. Think about that. Entire sections of the ship's interior, complete with bunks, bulkheads, even lighting fixtures, fabricated in covered workshops away from the building ways, then transported by massive cranes to be welded into place. It was parallel construction on a scale never attempted before. While one team was assembling the bow section, another was working on the stern. While the hull was taking shape on the ways, the superstructure was being built in a separate yard. The engine room equipment, massive reciprocal steam engines, was being installed into hull sections before those sections were even attached to the ship. Traditional shipyards looked at this process with horror. It violated everything they knew. Ships, they insisted, must be built from the keel up, each piece carefully fitted to the piece before it, accounting for the natural stresses and settling that occurred during construction. Kaiser didn't care. He'd seen how Ford had transformed automobile production by breaking the manufacturing process into discrete, repeatable steps. He'd seen how interchangeable parts and standardized assembly could multiply production rates exponentially. And he proved the old guard wrong. By 1943, Kaiser's Richmond shipyards, he eventually operated 7 major yards, employed nearly 100,000 workers. These weren't traditional shipwrights. Many had never seen the ocean before. They were farmers, housewives, teenagers, retirees, anyone who could learn to operate a welding torch or drive a rivet. Yes, some rivets were still used in non-critical areas. And here's something that often gets overlooked in the narrative. This industrial mobilization fundamentally changed American society. Rosie the Riveter wasn't just propaganda, she was real. Women comprised a significant portion of the Liberty ship workforce, often outperforming their male colleagues in welding quality and productivity. The shipyards became some of the first major American industries to hire African Americans in non-menial positions, paying union wages. The Liberty ship program didn't just build vessels, it helped build the modern American workforce. Now we come to the numbers that still seem impossible even knowing they're true. In 1941, when the program began, the average construction time for a Liberty ship was about 230 days, roughly 7.5 months. This was already considered impressive, cutting traditional construction time nearly in half. By 1942, Kaiser's yards had reduced that to 42 days average. 42 days, 6 weeks, a month and a half to build a 10,000-ton cargo vessel. Let me give you some context for how extraordinary this was. Britain's best emergency shipyards were still taking 4 to 5 months per vessel. Japan, despite its vaunted naval construction capabilities, required similar timeframes for equivalent cargo ships. The Germans, with their emphasis on U-boat production, had essentially given up on merchant vessel construction. But America was building Liberty ships so fast that we were launching them faster than we could name them. Eventually they bore the names of deceased Americans, patriots, pioneers, scientists, educators. Every Liberty ship was a floating memorial to someone who'd helped build the nation. The Robert E. Peary, our 4-day record holder, was designated number 440 in the Liberty ship program. By the time she slid down the ways, Kaiser's yards had already delivered hundreds of vessels. They would deliver hundreds more. Here's how they achieved that record, because the details matter. The keel was laid on November 8, 1942 at 12:01 a.m. Every component had been pre-manufactured, inspected, and staged. The hull sections were assembled with such precision that welders reported seams that required minimal adjustment, unheard of in traditional construction where fitting and adjustment consumed enormous amounts of time. 18,000 workers operated in 3 shifts around the clock. The coordination required was staggering. Cranes moved in choreographed precision, lifting 40-ton sections into place within minutes of the previous section being secured. Welders worked in teams, multiple torches creating a constellation of arc lights that turned night into perpetual artificial day. By November 12th, at 3:29 p.m., the Robert E. Peary was complete. Not just structurally complete, fully operational, engines tested, cargo holds ready, crew quarters equipped. She was immediately loaded with war materials and departed for the Pacific Theatre within days. 4 days, 15 hours, 29 minutes. But here's what matters more than the record. The average kept dropping. By 1943, Kaiser's yards were completing a Liberty ship every 30 days on average. Some yards achieved 24-day construction times. The industry as a whole settled into a rhythm where a new Liberty ship was being launched somewhere in America every 8 hours. Let me put this in perspective. The German U-boat fleet, at its peak operational strength, numbered around 450 boats. In 1943 alone, America built over 1,400 Liberty ships. Even if every U-boat sank one merchant vessel, which they couldn't possibly achieve, we were still building ships 3 times faster than they could be destroyed. Dunitz's calculus had been shattered by American industrial capacity. Now, I need to be honest with you about something, because complete history demands it. The Liberty ships weren't perfect. Far from it. The very innovation that made them possible, electric welding, also created vulnerabilities that riveted construction might have avoided. Welded seams, when they failed, could propagate cracks rapidly through the hull. Riveted construction, by contrast, tended to contain failures. A crack would stop at the rivet line. In cold North Atlantic waters, some Liberty ships experienced catastrophic hull failures. The SS John P. Gaines broke in half in the Aleutian Islands in November 1943. The SO Manhattan, a tanker built using similar methods, split completely in 2. Between 1943 and 1952, approximately 30 Liberty ships suffered serious hull fractures, and at least 3 broke completely apart with loss of life. The investigation revealed a problem that metallurgists today call brittle fracture, a phenomenon that wasn't fully understood in the 1940s. The steel used in Liberty ship construction, while adequate for most conditions, could become brittle in cold temperatures, especially around welded joints where internal stress is concentrated. This wasn't a failure of effort or attention, it was the cutting edge of materials science encountering its limits under wartime pressure. The Maritime Commission responded by reinforcing critical stress points, modifying steel specifications, and improving quality control on welding procedures. Later, Liberty ships incorporated these lessons with significantly improved structural integrity. But here's the hard truth. Even knowing about these structural issues, the Liberty ship program remained absolutely essential. Because the calculus of war is often about acceptable losses versus strategic necessity. By mid-1943, the tide of the Battle of the Atlantic had turned. Not because U-boats became less effective, German submariners fought with desperate courage throughout the war. The tide turned because we were simply building ships faster than they could sink them. The mathematics of attrition, which Dönitz had counted on working in Germany's favour, had reversed. In 1942, Allied shipping losses peaked at over 1,600 vessels totalling 8 million tons, but American shipyards, led by the Liberty ship program, launched 746 ships, totaling over 5 million tons that same year, and the production rate was still accelerating. By 1943, American yards launched 2,710 ships, totaling nearly 19 million tons. German U-boats, despite their most intense operational period, sank about 3.2 million tons of Allied shipping. Terrible losses, absolutely, but less than 1/5 of new construction. The famous German Admiral Karl Dönitz would later write in his memoirs, and I'm paraphrasing his sentiments here, that he'd understood by late 1943 that the U-boat war was mathematically unwinnable. Not because his submariners lacked courage or skill, but because American industry had achieved something unprecedented in military history, that to replace losses faster than they occurred. Let me tell you what that meant in practical terms. Every Liberty ship that reached Murmansk in the Russian convoys carried enough supplies to equip a Soviet division. Every Liberty ship that reached Britain carried food to prevent rationing from becoming starvation, fuel to keep factories running, raw materials to build aircraft and tanks. When Allied forces landed at Normandy on June 6, 1944, the invasion was possible because Liberty ships had maintained the supply line that built up British forces, that transported American armies across the Atlantic, that kept fuel flowing to training bases and ammunition flowing to depots. When General Patton's tanks raced across France in the summer of 1944, they ran on fuel delivered by Liberty ships. When the strategic bombing campaign reduced German industrial capacity to rubble, those bombers flew missions fueled and armed by supplies carried across the Atlantic in Liberty ships. The Liberty ship didn't fire a shot. They were cargo vessels, after all, not warships. But they were the logistical backbone of Allied victory. Here's a statistic that captures this. During the war, Liberty ships carried roughly 70% of all cargo shipped to Allied forces overseas. 70%. That's not just supplies, that's the entire war effort, floating on welded steel hulls built in American shipyards. By the time victory in Europe came in May 1945, American shipyards had launched 2,710 Liberty ships. Add in the victory ships, an improved design that followed. And we're talking about nearly 3,000 emergency cargo vessels in less than 4 years. For context, that's more merchant shipping tonnage than Britain built in the entire 20 years between world wars. So what happened to these ships after the war? Some served for decades. Liberty ships showed up in commercial service well into the 1970s, hauling cargo under flags from dozens of nations. They were simple enough to maintain, capacious enough to remain economically viable, and tough enough, despite those early structural concerns, to weather decades of hard use. Others were converted. Liberty ships became training vessels, floating warehouses, even research platforms. The SS Albert M. Bow served as a floating power plant in Greece for years. Several became museum ships, permanent monuments to the industrial mobilization that won the war. But most were scrapped. By the 1960s and 70s, as maritime technology advanced and containerization revolutionized cargo shipping, the Liberty ships became obsolete. They were cut apart in shipbreaking yards, their steel recycled, which seems somehow fitting, given that they were built for expediency rather than permanence. Today, only 3 Liberty ships survive as museum vessels: the SS Jeremiah O'Brien in San Francisco, the SS John W. Brown in Baltimore, and the SS Arthur M. Huddle in Greece. If you ever get the chance to visit one, I cannot recommend it highly enough. Stand on the deck of a Liberty ship and you're standing on the physical embodiment of industrial warfare, the moment when American manufacturing capacity became a weapon as decisive as any bomb or bullet. But the real legacy of the Liberty ships isn't the vessels themselves. It's what they proved possible. They proved that traditional methods, no matter how refined by centuries of practice, could be completely revolutionized when circumstances demanded it. They proved that American industrial creativity, given a clear objective and necessary resources, could achieve things that seemed impossible by conventional wisdom. And they established principles that echo through manufacturing even today: modular construction, prefabrication, standardization of components, parallel engineering. These weren't invented for Liberty ships, but they were proven on Liberty ships, demonstrated at a scale that transformed them from interesting concepts into fundamental industrial practices. When Boeing builds an aircraft today using modular assembly, with fuselage sections manufactured in different countries and brought together for final assembly, that's a direct descendant of Liberty ship construction principles. When automobile manufacturers coordinate global supply chains to build vehicles from components manufactured on 3 continents, that's the Liberty ship paradigm scaled to modern logistics. Henry Kaiser, that construction engineer who'd never built a ship before 1941, went on to found Kaiser Permanente, one of America's largest healthcare organizations. He applied the same principles he'd learned building ships: standardization, efficiency, making services accessible to working people who'd traditionally been excluded. The workers who built Liberty ships, those welders, crane operators, administrators and engineers, they became the post-war American workforce. They'd learned they could do things that had seemed impossible. They'd learned they could master complex skills rapidly. They'd learned that with proper organization and sufficient determination, Americans could accomplish literally anything. That confidence, that sense of possibility, that was as much a product of the Liberty ship program as the vessels themselves. Let me bring us back to where we started: Richmond, California, November the 12th, 1942. The Robert E. Peary, constructed in 4 days and 15 hours, would go on to serve in the Pacific Theatre. She survived the war, unlike too many of her sister ships. She carried supplies, equipment, and hope across thousands of miles of dangerous ocean. But she was never meant to be special. That's the point. She was Liberty ship number 440, one of thousands, built to a standardized design, assembled from prefabricated components, welded together by workers who were doing the same thing, happening in 6 other shipyards at the same moment. The Robert E. Peary's record wasn't meant to show that ships could be built in 4 days. That was obviously unsustainable. It was meant to show that with proper organization, sufficient resources, and American industrial determination, the supposedly impossible became merely difficult. Every soldier who waded ashore at Normandy, every airman who flew missions over Germany, every tank crew that rolled into Berlin, they were there because Liberty ships had kept them supplied. Every British family that survived the darkest days of 1942 and 1943 did so, partly because Liberty ships had kept the supply lines open. The U-boats couldn't sink them faster than we could build them. The Atlantic couldn't claim them faster than American shipyards could launch them. And in that simple mathematical reality lay the foundation of Allied victory. We didn't win World War II just with better soldiers. Though our soldiers were brave and capable. We didn't win just with better weapons, though American equipment proved itself again and again. We won because we could build ships in 42 days. We won because welders in Richmond and Portland and Baltimore worked in shifts around the clock, creating vessels faster than anyone in history had imagined possible. We won because when freedom needed a lifeline, American industry built one, 2,710 times over. The men and women who built the Liberty ships, most of them have passed now. They were young then, in the 1940s. They're part of that generation we call the greatest generation, though I suspect many of them would have just called themselves Americans doing what needed doing. But before they fade entirely into history, before the last Liberty ship worker passes and the last vessel is scrapped, I think we owe them this, to remember that they did something extraordinary. They took the impossible and made it ordinary. They took a crisis that threatened to strangle freedom and turned it into a testament to what free people can accomplish when they work together toward a common purpose. The Liberty ships weren't the most glamorous part of the war. They didn't earn medals or make headlines, except for brief moments like that 4-day construction record. But they were the foundation that made victory possible, and in an age when we sometimes wonder if we've lost that capacity for great collective effort, when we question whether we could still achieve such things if we had to, the Liberty ships stand as proof. We did it once, we could do it again,